.3363. Oh, I did 0.0. I'm like, I'm not matching my notes here, but it's good. Over 0.1. And now when I divide, I'm going to get 26.3363 degrees per second. Make sure you're labeling. So, in this problem, we're going to do another one here. We kind of interpreted what we had to do to estimate how fast the door was moving at 1 second. There was no way for us to tell just at 1 second its speed. I just knew where. Oh, I wrote those on the wrong graph. See, you're going to see I make mistakes because I've got no one to tell me that I'm making mistakes. So I wanted to label it at the 1 and the 1.1. And this is way exaggerated on the graph. And what we did was we just took the change in here to see, kind of like we actually just did slope. We did the change in time, or the change in degrees over the change in time. So we took the slope of that line. Now this is just an estimate of how fast the door is moving at 1 second, because I had to use this other value that was away from the 1. That's why this is giving us an estimate, not an exact rate of change. So this whole process here was an estimate. Later on in the other chapters, we're going to find ways to do this exactly. Okay, we're going to get a more accurate answer in part B for how fast that door is moving at 1 second. Get a more accurate answer to the rate that the door is opening at 1 second. So, if you think about it, how can I get a more accurate answer than this 26.3363 that I got? Well, remember I did 1 to 1.1. Well, the only thing we can do is maybe get our second value closer to 1. And then get closer again and keep moving in close to that 1 and see what happens. So we're going to do that. So I'll make a little table again. Well, I want time. That's a T and a degree. So 1 is what I'm trying to estimate the speed at. I know that's 100 degrees. Now I want to go to, say, 1.01. I don't know why I made that table so big. I don't want it that big. Okay. So I'm going to practice that table set feature. You should probably practice that instead of the trace. Table set. I want to keep the 1, but this time I want to go by 0.01. And you are going to want to get your cursor on that Y value so you can see all of these decimal places. And like I said, 5 or 6 is usually pretty good. So I've got 100.3023. And if I want to estimate the rate of change here, or how fast the door is going, I need to take the change in the degree over the change in time, so I get degrees per second. So 100.3023 minus the 100, that's going to give me the change in degrees, over the change in time. Divided by 0.01. 30.23, give me a label, degrees per second. I had to squeeze that in. So I came up with 30.23 degrees per second. So that's a little bit faster speed than the first one I got using 1.1. Well, let's see if I can get more accurate. Okay, pretend I started a new table here. 1, I know is 100 still. Get closer to 1 than 1.01. I'm going to go 1.001. So I'll go back to table set, change this to 0.001, and go back and look at the table. And again, you can't just look at what's in the table because the table only shows you five places and it chops it off. You got to get on it and then it shows you all the decimal places down here. So I got 100.03064. If I do the subtracting, I don't think it's necessary for me to write it out here. I get 0.03064 divided by 0.001 when I subtract here. That'll kick the decimal over 3 places. 1, 2, I get 30.64 degrees per second. Still got a little bit faster estimate. Remember, this is an estimate I'm doing, not exact. Let's go one more. Get a better estimate. So I got 1 second and then 1.0001. 100. Table set. You can see how graphing calculator makes these a little bit less painful. 0.0001, is that what I was on? 1, 2, 3, yep. So if you just look at here, it looks like they're exactly the same. But once I get my cursor down here, you can see where we're at. I got 0.003068. That should be good. So when I forgot my 100. 100.003068. Okay, now I want to turn this into a rate of change. So I want the change in degrees over the change in time. So when I subtract this one minus this one, 0.03068, subtract my time values, 0.0001, kick the decimal over 4 places, at 30.68 degrees per second. And we could keep going here and get more accurate, but you can see we're pretty close now. I mean, they're all staying in the 30s, 30.64, 30.68. We could go one more, but I don't think we need to. Oh, well, maybe. Let's one more. What the heck? Nah, good enough. So we've got a very good estimate of the rate that the door is moving at 30.68 seconds. And on our graph, can you tell me if this door was opening or closing? Well, if you look at 1 second, you can see the degrees are still getting bigger and bigger and bigger, so that means the door is opening wider and wider and wider. So we can tell, because I'm here on the graph, on this side of the graph, the door is opening, then you can see here's where it stopped, and now it's closing. So here, at 1 second, that door is opening at approximately 30.68 degrees per second. So I want to try one more of these with the same door and ask you at a different time how fast the door is moving. Okay, part C. I would like you to estimate the rate of change of the door at time equals 4 seconds. So our rate of change, we're talking about dividing the change in the two variables. And in this case, that's going to give us a speed, how fast the door is changing. Because we're going to take the change in degrees over the change in time. Okay, so I want to do the same kind of thing I just did over there. So let's make the table. We'll just put it all in one table instead of making the different tables this time. And then the degree. So we want it at 4 seconds. I'm going to go to I'm going to skip the 1. I'm going to go to 0.01, 0.0001, and 4.0001. Let's do 3 rates of change and see what we get. So all I'm doing is the closer I get to the 4 with my second point, the more accurate my estimate is. So we'll go back. I'm going to use that table set. This time I want it to start at 4. And I'll go by 0.01 because I think that's my first one that I have. Yep. So at 4 seconds, the door is at a 50-degree opening. At 4.01, it's at 49.77. And again, at least 5 or 6 decimal places you want to carry out on these. 49.778. Oops. 77876. Yeah, you're going to find through the videos I do make mistakes and don't catch them, but I make mistakes. That's all I can tell you. There's nobody here to fix them for me or let me know I'm making them. So I'll go back to table set. I want this 4.001 value. I'm going to change this to 0.001. I'm reading down here at the bottom. 97785. And I'm going to go one more. 0.0001. 49.99778. Okay, and now we're ready to do our rates of change. So I need to subtract these two. Now be careful, the order you subtract makes a difference. Take a look back here. We were always taking the second value, the higher time value, its y value, minus the previous one. Well, when I do that here, I'm going to get the 49.77876 minus 50 over the change in time here is a 0.01. I don't have to show that subtraction. We'll do that one. Now I want to go with these two, the change from 4 to 4.001. So I'm going to take the 49.97785 and subtract the 50 over my change in time is 0.001, and then the last one, we're going 50 to this last one here, so 49.99778 minus the 50 over 0.0001. That'd be this minus the 4. Okay, let's do those 3 problems. See what we get here. 49.77876 minus the 50. Got a negative 0.22124 over 0.01. So when I kick it over 2, I get a negative 22.124, and my label would be degrees per second still. This time negative. Why do you think that is? What could a negative rate of change mean? Well, we'll find out in a second. You might know already. Okay, doing the next one. 49.97785 minus the 50. Negative 0.022115.